What's up, guys? So today is Friday the 25th. Now, what I'm going to have you guys be doing today is learning how to read and answer a velocity time graph. So a velocity time graph, all right, is pretty much, it's very similar to a DT graph, but you're looking only for a few different things now. So instead of having distance on the x-axis, distance on the y-axis, instead of that, now you're going to have speed. You're going to have speed there instead. So these are what you're going to wind up seeing, and these are what they mean. So time is on the x, speed or velocity on the y. So when you're having positive slope, that means you're increasing your speed. You have a positive acceleration. A flat line on a specific speed value is indicating a constant speed or a constant velocity. Again, all right, it is accelerating, not as much as it is here. And then a negative slope is, all right, telling you that the object is slowing down. Once the item or once the object is on the x-axis, all right, so if this thing flatlined was all the way down the x-axis, it would have a speed of 0, and it would be not moving. Okay. So horizontal line on the 0 means the object is at rest. So just kind of going through and taking a look at a few different things. All right, here you're going from 0 to 10. All right, you're doing that in 5 seconds. So you would use the acceleration equation, VF minus VI divided by t, to figure out what the object's acceleration is. So the final velocity is what it is at this time frame, which is 5 seconds, 0 to 5 seconds. So we'd go to 5, go up, you're at 10. 10 minus 0 divided by the time of 5, and you're going to get your acceleration. The units, again, are meters per second squared. So you can see you're accelerating. Here you're at a constant speed of 10 meters per second. You're not accelerating. You have a constant speed here. Here, you're slowing yourself down. You were all the way at 10, and then you hit 0 on the x-axis. I'm sorry, you hit here on the x-axis, and if you scoot over, that's going to tell you that you're at 0 meters per second on the y. So from C to D, you're at rest. D to E, you're all right, accelerating. You're speeding up. E to F, a constant speed. What would your constant speed be there from E to F? Well, it's a horizontal line. So if I just scoot this across, boom, smack dab in the center of the 6 and 4. So I'm at 5 meters per second. Okay, so that is some notes, guys. That is I gave to you, all right, in your materials there, all right, for week 3. The other one is just the same thing, just maybe a little bit clearer, and it doesn't have like the little answers on there. The next thing that you guys are going to wind up doing is looking at this guy and reading a VT graph. So these are the two equations that you're going to use: finding acceleration and then finding your distance traveled. So the distance traveled is basically, you know, your area under the curve, kind of a deal. And then even when you go negative, it's, you kind of like would flip it. If you're looking for distance, you just get rid of the negative. If I ever ask you guys for displacement, then you would need to wind up using the negative in the answer, but I'll get to that. So these are our two equations. You need to figure out VI, VF, and T. So how we're going to do this from 0 to 2 seconds. Well, find 0 seconds. Boom, there it is. And go up until you hit your line. Okay, there it is. It's at 10. So my initial velocity, you're going to write it out, 10 meters per second. My final velocity, so what is my speed at 2 seconds? So I go to 2 seconds, go up. I have a final velocity of 10 meters per second. And how long was I moving for? It's the time difference between these. All right, so what's the difference between 0 to 2 seconds? It's 2 seconds. All right. Once you guys have those, then you can solve for the acceleration. Here's your equation. It's VF minus VI divided by T. Okay. Be very, very careful because some people have been using, all right, VI minus VF, and you'll wind up getting a wrong answer if you do that. So in this case, it's not going to matter because they're the same value, and there should not be an acceleration because 10 minus 10 is 0. 0 divided by anything, all right, is 0. So you're going to get a 0 for an acceleration here. Now the unit is meters per second squared. So to get the square function on a Google Doc, you hit Control period, and you should see the cursor jumped up a little bit. Then you can hit your 2 for the squared part, and then Control period to get it to come back down. All right, so now to find the distance, you're going to use this equation. We're just going to do 1/2 of VI, which was 10, plus VF, which was also 10, times our time, which was 2 seconds. Okay, we're going to put this into a calculator. I'm using the free calculator here. All right, so 1/2 times what was in the parentheses, 10 plus 10, all right, and times that by 2, telling us that we moved 20 meters. Once you guys have done, the acceleration and the distance, I would like you to please highlight that, pop it in, put it down for red. Okay, and then you guys are going to repeat, all right, the process, finding VI, finding VF, T, all right, plugging it into the acceleration equation, plugging it into the distance equation. Now, just remember that if you do have a negative slope, you're going to wind up with a negative acceleration. You should, right? Because think about it. You went from 60 here to 50. So your answer for the acceleration part of this, from that 5 to 10 second mark, all right, from 5 seconds to 10 seconds, should be a negative value for acceleration. That's okay. Distance, though, distance is not going to be negative. Now, I wrote here total distance traveled. So you're going to add, once you've done these, all right, all 3 of these, you add all of them together, and you're going to get a final answer, which you'll put there. Okay, the next graph is going to be done the same way. It's going to be done the same way. You have to go through and determine, all right, your initial speeds, or your initial velocity, final velocity, and the time. So we can do an example from here. Let's say we're doing the 2 to 3 second guy. You're doing 2 seconds, so 2, go to the time of 2 seconds, go across. So your initial velocity here, excuse me, it's going to be 2 meters per second. My final velocity would be whatever it is at the 3 second mark. So I go to 3 seconds and I go up until I hit my line, ba-bam, I'm at 6 meters per second. What is my time frame? Well, what's the difference between 2 to 3 seconds? It's 1 second. All right, bet. So the acceleration just goes in. VF minus VI. Okay, that's the equation. Make sure you're using that equation. So VF was what? 6 minus VI, which was 2, divided by the time of 1. 6 minus 2 is 4. 4 divided by 1 is 4. So 4 m/s, meters per second squared. So you have to do the square. Again, it's Control period. Cursor jumps up. There's your 2. There's the squared. Look, looks nice. Okay, distance. Again, you're doing the same idea. 1/2 of VI plus VF in this case. So 2 plus 6 times our time, which is just 1. So 2 plus 6 is 8. Cut it in half is 4. 4 times 1 is just 4. So you've moved a total of 4 meters here. Okay. Now you're going to go through. You're going to go and solve for the accelerations. After this, you're not going to solve for the distances because when we do it like that, it has to deal with the fact that it's the area under the graph, under the curve. So the equation I have for distance is 1/2 VI plus VF times T. So like in the problem that was like 7 to 10 seconds, well, if you went from a VI of 6 and a VF of -10, I'm sorry, of -3, and you do it, you wind up getting a funky kind of an answer. So the area basically for a triangle is 1/2 base times height, kind of a deal. So you would have had to have broken it down into 7 to 9 seconds and getting 6 meters that you moved, and then because if you use that full time frame, you would also get this as the area under the curve, but it's no longer there because, all right, it's now gone in the opposite direction. Once it crosses over the origin, now it's telling us it's moved in the other direction. So technically, this is now the area under the curve for that 9 to 10 seconds. So this would have been a 1.5. So from that time, from 7 to 10 seconds, it would have been a total of 7.5. Then from 10 to 12, you're moving in -3 meters per second for 2 seconds. All right, that area would be this boxed here. And if you did the equation, -3 plus -3, cut it in half, multiply it by 2, you're going to get a -6, but we're just dropping the negatives because distance doesn't care about negative. All right, it would if we were asking for displacement. Then you would leave the negatives down, but I'm not, so you're not having to worry about it. All right. So guys, yes, that is what I'm going to have you guys be doing, and we are going to be having a test coming up next week. I'm shooting for Tuesday, and so once we have that kind of squared away, yeah. All right, so our test will be on distance and speed, displacement, velocity, vector scalar, DT graph, which we had done the past 2 days, VT graph, which we did today. We're going to do a little bit of another one on Monday, and then Tuesday, hope to have our test done. Okay. All right, guys. Hope this helps.